Understanding Ethereum gas fees. Picture this. You're about to mint that perfect NFT, your finger hovers over the confirm button, and then, bam, a $50 gas fee for a $10 transaction. Welcome to Ethereum, where sometimes the toll costs more than the journey itself. But before you throw your laptop out the window, let's dive deep into what gas fees actually are and why they're not just Ethereum's way of trolling us. What exactly are gas fees? Spoiler, it's not about your car. Gas fees are essentially the cost of doing business on the Ethereum blockchain. Think of Ethereum as a massive, distributed computer where thousands of nodes work together to process transactions. Just like how your laptop heats up when running intensive software, the Ethereum network requires computational energy to execute smart contracts and process transactions. Gas is the unit that measures this computational work. Every operation on Ethereum, whether it's sending ETH, swapping tokens on Uniswap, or minting an NFT, requires a certain amount of gas. The gas fee is what you pay miners or validators post-merge to prioritize and include your transaction in a block. The anatomy of gas fees, breaking down the numbers. Gas fees aren't just random numbers thrown at you by the blockchain gods. There's actually a method to this madness. The total gas fee is calculated as base fee plus priority fee times gas used. Simple math, but the implications can be wallet draining when the network gets congested. Let's break down the key components. Base fee, the minimum cost per unit of gas burned and removed from circulation. Priority fee, tip extra payment to incentivize miners to process your transaction faster. Gas limit, maximum amount of gas you're willing to spend on a transaction. Gas used, actual amount of gas consumed by your transaction. Why do gas fees fluctuate like crypto prices? If you've been in the Ethereum space for more than 5 minutes, you've probably noticed that gas fees have more mood swings than a teenager. 1 minute you're paying $5 for a transaction. The next it's $100. This volatility comes down to supply and demand economics. Ethereum can only process about 15 transactions per second. When demand spikes, maybe because of a hot NFT drop or a DeFi protocol going viral, users start bidding higher gas fees to get their transactions processed first. It's like an auction where everyone's trying to cut in line, and the auctioneer, the network, goes to the highest bidder. Quote, gas fees are the free market's way of allocating scarce block space. When everyone wants to transact at the same time, prices go up. It's economics 101, but with more blockchain and frustration. Ethereum community wisdom. EIP 1559, the London upgrade that changed everything. In August 2021, Ethereum implemented EIP 1559, which fundamentally changed how gas fees work. Before this upgrade, gas fees were a Wild West auction system. After EIP 1559, the system became more predictable with the introduction of base fees and priority fees. The base fee gets burned, permanently removed from circulation, making ETH deflationary during high network usage. The priority fee goes to miners as a tip. This system made gas fee estimation more reliable, though it didn't necessarily make fees cheaper. That's a job for scaling solutions. Smart contract gas consumption. Not all code is created equal. Different operations on Ethereum consume different amounts of gas. A simple ETH transfer might cost 21,000 gas, while a complex DeFi transaction involving multiple smart contracts could cost 500,000 gas or more. Let's look at some code examples. Three Solidity functions demonstrating different gas consumption levels. The transfer ETH function simply transfers Ether using the recipient.transfer method consuming about 21,000 gas. The transfer function is an ERC0 token transfer that includes balance checking with require statement, updates balance of mapping for both sender and receiver, emits transfer event, and returns Boolean, consuming around 65,000 gas. The swap and stake function is a complex DeFi operation that first transfers token A from message sender to the contract using transfer from, swaps token A for token B on a DEX using the swap function, approves the staking contract to spend token B, stakes the received tokens, and mints a receipt token to message sender. This complex operation can consume over 200,000 gas due to multiple external contract calls and storage operations. Gas optimization, making your code wallet-friendly. Writing gas-efficient smart contracts is both an art and a science. Here are some techniques developers use to minimize gas costs. Use uint 256 instead of smaller integer types. Ethereum's virtual machine is optimized for 256-bit operations. Pack struct variables efficiently to minimize storage slots. Use call data instead of memory for function parameters when possible. Implement batch operations to amortize fixed costs across multiple actions. Cache storage variables in memory for repeated access. Comparison of gas-inefficient and gas-optimized smart contract code. The bad example contract uses memory arrays for parameters and performs multiple storage writes in a loop without caching array length. The good example contract demonstrates optimization techniques, uses call data instead of memory for function parameters to reduce gas costs, caches the users.length in a local variable length to avoid repeated array length lookups, uses unchecked increment ++i to save gas by skipping overflow checks, implements batch transfer function that calculates total amount first in memory, performs single storage update by subtracting total amount from sender balance once, then updates all recipient balances. In a separate loop, demonstrating how batching operations and minimizing storage operations significantly reduces gas consumption. Layer 2 solutions, the light at the end of the gas fee tunnel. While we wait for Ethereum 2.0 to fully roll out, Layer 2 solutions are providing immediate relief from high gas fees. These solutions process transactions off the main Ethereum chain and then batch them together for final settlement on Layer 1. Popular Layer 2s like Polygon, Arbitrum, and Optimism offer transaction costs that are often 100x cheaper than mainnet Ethereum. The trade-off? You need to bridge your assets to these networks, and not all dApps are available on every Layer 2. Gas fee strategies. Timing is everything. Smart users have learned to game the gas fee system. Network activity follows predictable patterns. Fees are typically lower on weekends and during off-peak hours, U.S. nighttime. Tools like Gas Tracker and ETH Gas Station help users monitor current gas prices and set appropriate fees. Quote, "The key to surviving high gas fees is patience and timing. Unless you're arbitraging or in a time-sensitive situation, waiting for lower gas prices can save you significant money in the long run." Defy veteran advice. The future of gas fees. What's coming next? Ethereum's transition to proof-of-stake was just the beginning. The roadmap includes sharding, which will dramatically increase the network's transaction throughput. Additionally, advancements in Layer 2 technology and the potential for proto-danksharding could make gas fees a thing of the past. EIP 4844, also known as proto-danksharding, introduces a new type of transaction that carries large amounts of data that can be used by Layer 2 networks. This could reduce Layer 2 costs by 1020x, making Ethereum truly accessible for everyday use. Gas fees might seem like an annoying tax on using Ethereum, but they serve a crucial purpose in maintaining network security and preventing spam. Understanding how they work, when they spike, and how to minimize them is essential for anyone serious about participating in the Ethereum ecosystem. The future looks bright with scaling solutions on the horizon, but until then, we're all just trying to time the market, both for our investments and our transaction fees. Remember, every time you pay a gas fee, you're not just moving money or tokens. You're participating in a global, decentralized computer that's reshaping how we think about finance, ownership, and digital interactions. That perspective might not make the fees hurt less, but at least you're part of something revolutionary. And hey, at least it's not as expensive as San Francisco parking fees, yet. Enjoyed this video? Hit the like button and subscribe to stay tuned for more.